Let's dive right into this explainer. Today, we're taking a standard biology lesson and turning it into a literal detective game that you can set up right on your kitchen counter. It's completely hands-on, super visual, and honestly, just a lot of fun. We're stepping out of the textbook today, guys. We are officially becoming starch detectives.
So, think about the humble potato. It just sits there in the pantry, right? Completely unassuming. But what if I told you this totally ordinary vegetable is secretly harboring a hidden treasure? In this explainer, we're going to channel our inner investigator to track down a secret tucked deep inside the cells of an everyday potato. It's an interactive mystery that brings the invisible world of plant biology right out into the open.
All right, moving into Section 1, Detective Tools. Time to gather our gear.
The best part about this? Your investigative toolkit is made up of stuff you probably already have lying around the house. First up, our primary suspect, a fresh potato. Next is the secret weapon, iodine solution. You know, that standard wound antiseptic you can usually find in the pharmacy. Take a really close look at its natural color. It's this very distinct dark brown, almost dark orange. You'll also want a dropper or just a plain cotton swab to apply the chemical, a small plate for our evidence, and a knife. Now, just a quick heads up, the knife is strictly for the adult chief inspector of the house to handle the prep work, okay?
Okay, Section 2, the investigation, setting the crime scene.
Let's walk through the exact protocol for our investigation. Step 1 is preparation. The adult chief inspector carefully cuts the potato right down the middle and places one half onto the small plate with that bright white inside facing straight up. Basically, you're setting up a blank canvas. Step 2 is prediction. And actually, we're going to talk more about that in a second because it's absolutely crucial for the learning process. Step 3 is discovery, where we carefully apply our iodine. And finally, step 4 is observation. We just sit back and watch the science unfold. Now, right here at step 2, prediction. This is where the magic really starts. Before you let a single drop of iodine fall, you absolutely have to hit pause. Look at your junior detective and ask this one specific question. Hey, look at the iodine in this bottle. What color is it right now? They'll tell you it's brown or orange. Then hit them with, so what do you think is going to happen the absolute second this brown liquid touches the white potato? Let me tell you, this builds so much suspense and really fires up their critical thinking before the big reveal.
And wow, this next part perfectly illustrates why science is so cool. You take your dropper, let just a few drops of that brown iodine hit the white, cut surface of the potato, and wait. Literally just a few seconds. Suddenly, right before your eyes, that brown liquid rapidly shifts. Boom, it transforms into this striking, vivid, dark blue, almost pitch black. I mean, it seriously looks like a magic trick. Just an explosion of dark color where there was only white and brown a few moments before.
Which brings us to Section 3, Secret Inspector, Unmasking the Culprit.
So what exactly is the science behind this trick? Well, the potato is actually incredibly smart. When a potato plant is growing, it absorbs sunlight and uses it to make its own food through a process called photosynthesis. But it doesn't just use all that energy at once. Nope, the smart potato takes that excess sun energy and squirrels it away for later. It hides it in the form of a secret white powder called starch. The inside of that potato is absolutely loaded with these hidden energy reserves.
And this is where the true identity of our iodine comes into play. In the scientific world, iodine acts as our trusty secret inspector. On its own, like we saw, it's just brown. But iodine has this very specific, instantaneous chemical reaction the exact second it contacts starch. The moment those two meet, they unite, and the iodine's color completely flips. It turns that intense dark blue as a brilliant visual alarm system. It is literally shouting, "Hey, look right here, I found the starch!"
Let's move to Section 4, Detective Challenge, Testing More Foods.
Now we can really level up this investigation by bringing in some new suspects from around the kitchen. It turns into this amazing comparative challenge. Grab some different foods and have your junior detective test them. Take everyday carbs, a piece of bread, some cooked rice, maybe some pasta. Because they are packed with plant-based starch, just like the potato, they'll immediately trigger our inspector's blue alarm and turn beautifully dark blue. But then contrast that with an apple slice, a cucumber, or even a piece of cheese. You drop the iodine on those, and nothing. It just sits there, remaining a dull brown. No color change simply means no starch is hiding inside.
And just like that, we've closed our case file. We've seen firsthand how a single drop of liquid can illuminate the invisible energy stores hiding inside our food, turning abstract plant biology into a super colorful, hands-on discovery. So I'll leave you with this provocative thought. As you walk through your kitchen today, glancing at all the boxes, bags, and fresh produce, what other foods are secretly hoarding energy, just waiting for a secret inspector to reveal the truth? Grab your tools, set up your plate, and see what kind of starch mysteries you can uncover today.